Hi, I'm Detlef, and welcome to another installment of the LCC channel. Today, we're going to do a walkthrough of the CDI, the Configuration Display Information. What is the CDI? Well, basically, it's a window into the node. You open it up through JMRI, and you get in there and you can see how it's configured. Keep in mind, the nodes themselves are already programmed with all the information they need to communicate with the rest of the layout, to understand what's going on out there. All what we need to do is configure the node itself to do what we need it to do for our layout.
Okay.
So the CDI is a tool that we'll use to configure that, to walk through it, and then to basically create the specific configuration you need for your layout. The analogy would be like on a DCC decoder. The decoder already comes pre-configured. It does all the sounds and all the motor controls and everything else, but you might want to tweak some things just to make it do the sounds or the motor control or whatever the way you want on your layout. Well, that's the introduction. We're going to now switch over to the computer and we'll take a look at the CDI. Alrighty, and here we are. Let's go ahead and open up Panel Pro. Opening up Panel Pro will give you the option of what network you want to connect to. Just set up however you want to set up your route. As I mentioned, you can find that on one of your other videos here that tells you how to connect it. Here's your selections, and we're going to go ahead and click on LCC if that's the way you chose it. You could also do Open LCB Recall. Then we just come down to Configure Nodes. That's it. Now what this is showing you here is your LCC network. In this picture, it's called Open LCB. Remember, they're the same thing, but here's the difference. Here's your Open LCB network. The first one is always the actual USB interface to your computer. So this is actually not configurable. If you open it up, you'll just see that there's some modules underneath it, but not any that are really accessible or usable. Now if we go to the next one here, check this out. We've got a number up here. That is that unique LCC identifier. We have a description of it, and that's something that's actually set up in the CDI. And we just click on this first one out here. Open the configuration dialog. By the way, down here you can also look at some information about that particular node. It tells you the model. We're going to be looking at a Signal-LCC, hardware Rev C, software revision C1D, and all this great information. But if you just click on the Open Configuration dialog, it is reading right now the information off that node. None of this information resides on the PC. It's actually resident on the network, on the node itself out there.
Wow.
Okay, so let's just walk through each of these sections. Again, up on top you have the name of the node, and it also has that unique address identifier. Remember that every single LCC node on the entire planet is going to have its own unique number. So that's right up on top. A little bit of identification information, RR-Cirkits, this is Signal-LCC, and this is information that we just talked about. Then we get into your node idea. This is actually where you can configure it. So LCC test layout Signal-LCB. So I could change that here and say for what? For the LCC channel. Now notice that it turned orange. That means it's still not written out to the node. If I just click on write, that goes away. Now I've actually uploaded that right onto the node. That's how easy it is. No description, and I can say for the LCC channel. Again, this is all showing that the orange indicates that it's local only at this time. I hit the right, and it's now uploaded. By the way, notice that you can save changed. That button down here on the bottom, you can go through and update all these things. You don't have to hit right every time. You can simply go through the whole node and do all the updates you want, and then just hit save changed, and boom, it actually then just uploads it. Okay, so that's the first block. And notice you can play with these little carrots here, and it collapses and brings them back and forth. So, okay, so let's collapse it just to make things a little bit more compact. Segment port I/O. Okay, remember the Signal-LCC has 1, 2, 3, 4, 5, 6, 7, 8 lines. Those are those configurable nodes that can be either set up as an input or an output. And we're going to get into that into another video. But for each of those lines, here's line 1, line 2, line 3, line 4, 5, 6, 7, and 8. So I'm just going to camp out on line 1. I'm not using it right now. You can put in whatever description you want. Here's where you set it up. Do you set it up as an output, and what is the function? Or do you have it set up as an input? If it's an output, you would pick one of these, and we'll get into that in another video. And if it's an input, you can have all these different selections of how that input will function. Now you can't have output and input both active at the same time. That's not going to work. Its little brain doesn't know what to do with that. But here's where you can select whether it's an output or an input. You can then move into the next block here where it gives you a choice for a delay, or sometimes there's noise on the line or whatever. Here you can put some sort of a time delay such that it ignores like chatter or debounce on a switch. Okay, does that make sense? Then you go through all your different line inputs. In line 2, this particular one is it's an occupancy detector for turnout. This is on my test layout. So I could describe it as occupancy detector, right, as normal. No output, right? It's an input because it's a detector coming into the node, so it's an active low, see? So when the signal is low, 0 volts, that means it's active. The opposite's true. It's inactive, the block is not occupied if it were to be high. Does it make sense?
Okay.
And then we move on to occupancy detector number 1, and then left lead, and here's the actual turnout. In this particular case, it does have an output. This is the output to drive the turnout motor. So this is now a steady active low. In other words, it'll be active when it's a low signal, it'll be inactive when it's a high, and we'll get into that. But there is no input function. It's been disabled. See the difference there? Line 7 I'm not using. In light, there's a push button. That line 8 has a push button on it. So again, it has an input but no output. Make sense? And that's about it on the selection. Now for each of these, let's go back to line 1. I can scroll down here and I'll do a whole section on this, but an input into the node will be a producer onto the LCC network. Does that make sense? In other words, when there's an input from a detection block or a switch or a push button, it's going to broadcast that to the whole network. So that is where it is a producer. If it's listening, if it's trying to run a turnout, it's an output from the node, but it's listening from the LCC network for some sort of information, it becomes a consumer. And here's where you set that up. So you have your choice of it either being a consumer or a producer. If it's a consumer, it's listening on the network for some sort of signal or command, and then it outputs some sort of command to like throw a switch. And if it's a producer, think about it, it's something that's detecting something off the layout or a push button or whatever, and it produces the signal that sends out to the LCC network. Think about the directions there. Anyway, so if you go back to line 1, which is not configured right now, take a look at this. As a consumer, if you set that up as a consumer, in other words, something that has outputs, you can set up a number of events, 1, 2, 3, 4, 5, 6 different events that happen. So take a look at how this reads. When this event occurs, this is your secret, that secret code. That's basically that's the numeric number of that address of that event. The line state will be changed to, and you've got all these different options. Is it on? Is it off? Is it toggling? Is it veto? We're going to get into that later, but this is where you set that up. And you can set that up for up to 6 different events as a consumer. Similarly, hang with me, if it's a producer, in other words, let's say it's a detection block and it comes in there, upon this action, the input goes on, or input goes off, or it goes to the output goes off, or the output goes on. All these different kinds of things can happen based on some sort of an input to the card, and it produces some sort of an event that is sent out to the rest of the LCC network. We're going to spend a lot of time in here in future segments, but this is really where you set up your logic or your behaviors of the node, how it behaves when it gets a certain indication. In other words, let's say you push a button. It produces a command that goes out to the layout. Something will listen for that, and it will consume that event and then switch a switch, for instance. Or a detection block detects something, it gets into the node, and now it'll produce a signal saying, hey, this block is occupied, and the consumers of that event will say, oh, if that's occupied, I need to switch this signal from green to red. Makes sense? Okay, so that's this block here. Now, I'm going to go ahead and collapse that down, and notice that you can do that for all your different I/O points. Okay, so they are all unique. So what I'm looking at here is an occupancy detector. Notice that here it has no output function, but it's an active low input. And then down here, since it's a producer, it doesn't consume anything, so the line state stays to none. But as a producer, upon this event, event 1, upon this action input on, this event will be sent. And notice, this is so cool, guys. It tells you exactly where that event gets used. It'll actually list them all out for you. So it's really easy. And yes, this is a long, complicated number, but you don't have to remember. You can look at it by seeing what it says right here in terms of a description that you can set up way back up here. Here's the description. It remembers that and it broadcasts that throughout your network, and you can always search for it. Actually, it's right here on the search function. Also, you don't have to type in this huge, massive, long number. You just use the copy paste. And again, we'll do this in another segment, but by using the copy paste, we can go ahead and just copy that very easily. We don't have to type in the number. Make sense? Let's go ahead and look at a consumer. Here's the, where's the turnout? Turnout. Okay, in this particular case, the turnout is an output function, active, steady, active, low, but as an input, it's disabled. Makes sense, right? And then you scroll down here, because it's a consumer, it's looking for an event and something to do. It's listening all the time to the network. When that event occurs, blah, 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 this output state will be changed to line on active. And think about this. Event 1 makes it active, which is like throw the switch one direction. Event 2, look what happened, line off inactive. So if you really think for a turnout, you only need to use these two events. The first one is to make it active, say that's thrown, and event 2 would be the turnout being normal. And right here, look at all these fun little list of things. Other uses of this event ID, it tells you right away all the different places on this node that are being used, that signal's being used. Okay, same for all 8 of these. All right, let's collapse that down. Now we get into an area where I really think is exciting, because not only do we have all this yes, no, if, then going on in the way you set up the actual inputs and outputs, but now you have segment logics. You can see here I've configured, I don't know, maybe a third of them. You can have up to 32 logic statements set up. What this area does here is for each logic you can have a description like 2R stop control point is occupied. Okay, so this is my signal, signal 2, red, stop, the control point's occupied. So for that logic, and I'll get into this in another segment, you go through and you configure that out. You know, if this particular set of variables is true, then the stop indication gets sent, and it gets sent out, and then the logic tells you how the signal will be displayed. Okay, and honestly, you know, there is so much going on here that we're going to need to do a whole separate section on this. Okay, and just like before, you can see all the different places where these signal, these LCC commands, consumer producers, are being used. All right. And again, for each of these logics, you can have up to 32 of them that you set up. You know, here's, for instance, this one's another stop. Here's the logic for a clear and proceed. Here's another stop, and so on and so forth. Now, I probably haven't set it up. I think if you do this right, you should have all your stops up front, and so it's executing that first, and then you have your permissives. And then finally, the last logic should be your clear, total clear, and that would indicate that it's the least restrictive logic. Anyway, we'll get into that in another one. All right, anyway, so the long story short is that I've got 32 logic statements that I can play with in this board. Now, the other thing is with this particular card, the Signal-LCC, is that you can really set up your masts. In other words, each of the signals themselves, instead of saying red light or green light on or whatever, you just set up the indication or the command that you want to present, whether it's proceed or stop or approach, clear, or something like that. And all these are set up in this mast. So basically in the logic, you just tell it, I need a stop indication, and you don't have to say if it's going to be 2 red lights or 3 red lights on top of each other, if it's a 3-headed signal. You just say, I need a command stop, and then this section down here on your signal mast will start decoding how that stop is supposed to show up. Okay, So I have a couple signals here, eastbound signal, westbound main. So let's just walk through one of these. Again, I don't know if there's I don't think we have enough time on this particular one, but you can set up your different rules. Rule 1 is stop, Rule 2 is clear, Rule 3 is take siding, and you could set this up. You can go up to 7 or 8 different rules for what you want to define as these different conditions. And then down here you tell them what it is. Is it going to be stop? Is it going to be restricting? Is it going to be slow, medium, approach, medium, clear, proceed? These are all pre-set up in here. You just have to map your different events to the mast, and then the mast will connect out to the individual lights. Right? Does that make sense? I think the way it's described, the way Dick describes it, it's a conservation of logic. You're just telling it send out a signal to stop or a signal to proceed, and then the logic inside the board decodes what the lights will have to do. Okay? And then you get down to the individual lamps. Okay, so each head has up to 4 lamps. So you've got usually red, yellow, green, and sometimes you might have a white or some different color out there, an amber or whatever. So you can go now through each of those individual lamps, and you can name them, and you can even make it a fast flash or a slow flash. All this is set up right here. You don't have to program like your flash rates or anything else like that. Even some of this cool stuff here. Where did I see this? You can do like a strobe, you can have a transition, you can do a H2 red flash. These are different kinds of appearances. Where did I just see this? I was just looking for something else. Oh yeah, lamp fade up here. You can set it up for incandescent or not. And this is really kind of a neat thing because it'll actually slowly light up the light and then dim it down as if those are incandescent filaments inside of your lamps and your masts. Pretty cool.
Wow.
The last section here, well, I guess it's not the last section. Let me collapse this. There's this track circuit section. I have to admit, as of the date of this presentation, I have not used that feature. But the idea of a track circuit is that you can actually have your logic set up so that once you have a clear or proceed or stop or restricting signal, indication at one signal, it'll automatically cascade to the next signal to say, well, if you're stopped, I need to show approach or something like that. And that's done through the track circuits down here. And then finally, there's segment rules. Again, this is something that I've not used. Apparently, this is set up with ABS, APP, or CTC. Again, I've not used this. I've just simply programmed in the logic up above. And then finally, you can actually go through each of the LEDs, each of the outputs on this board. And remember, on the Signal-LCC, what is it? 8 discrete I/O that can be inputs or outputs. And then there's 16 LED outputs, dedicated LED outputs. And you can actually set the individual lamp intensity. So you just put your current limiting resistor in there. Well, in fact, the current limiting resistor is already on the board. You don't even have to do that. You just took your LEDs straight into the board, and then by using these variables here, 128, 128, or 20, this particular LED was super efficient. So I had to actually slow down or lower the intensity of that light that much compared to the one above it. So it looks appearance-wise about the same. And you can actually do that right from here. At the very bottom here, this one's usually collapsed, and I'm going to just do a quick introduction to it, is the sensor turnout creation. It's kind of hidden here. Notice it's collapsed right from the get-go. But this little box down here allows you to automatically, or more or less automatically, create the JMRI Panel Pro I/O point in from the CDI function simply by here make a sensor or make a turnout. Again, we'll do a segment on that. It's really slick way so that once you get all this configured on the upper half of the CDI, that you just can basically forward that information over to Panel Pro, and then you've got the opportunity to configure those points inside of Panel Pro. Anyway, there you have it. Quick introduction, a little bit longer segment today, but I hope it was useful. Again, as always, go ahead and ask any questions in the comments section. I'll try to configure it such that future segments will answer some of those questions, and if not, I'll just answer directly into the comments section below. Thanks for your time. and we'll talk to you later. Have a great day.